All right, ladies and gentlemen, welcome to finding the nth root. So we're getting really deep into algebra where we start having the idea of a proof or the idea that we just have a general way to think about things. That's kind of what a proof is really doing, is taking all these general ways of doing something to say generally here's a rule that we can follow. Before this, you had a core concept that basically says, and I'm paraphrasing, n being the root and a being why can't I think of the name? A is what's being rooted. We'll just say that. Because this is, the radicand. This is called the radical. The number inside is called the radicand. I had to write it down. That's why I couldn't think of it. Now, you don't have to know specifically this. Just know that it's the number that we're finding the radical of. And I misspelled radical, but that's okay. I teach math. Anyway, I'll go more in depth in the second video. But here, what we really want to pay attention to mentally is n even or odd? In this case, it's odd. So I'm only going to have one real answer. Think about it this way. The square root of 4 can actually be -2 or +2, but the square root of -4 can only be a negative number because you can never multiply nothing but positive numbers and get a negative number. So since this is odd, I know that I will only have one answer. It can be positive, it can be negative. Since A is negative, I know my answer has to be negative, okay? So how I write this is I'm gonna start here, and A goes under the radical, and n becomes the root that we're finding. So notice where I put the n is attached to the radical sign, not the a, or the radicand. It's very important. Remember, back with exponents, the exponent belongs to the base. Here it looks like a is the base, and that's fine. If you want to connect those two just to have an idea of what we're talking about here, that's fine. It's not actually the base, but I get the idea, the association to help you think if that's how you're thinking. If you're not, understand that this is the radicand, but the root belongs to the radical. So the n goes on the outside. So how I'm going to use that is 3 radical 3, or the cube root of -27. Now, again, this can only have one answer. So I'm not going to worry about whether that number is negative or positive at this point. I'm going to put a bookmark on it and say somewhere down here I'm going to have my answer, and it's got to be negative. So I go ahead and do that because that 3 is odd. Then I'm going to think of all the numbers that multiply up to 27. I know 3 and 9, but this number right here tells us we need 3 of the same number. Right now, I've only got 2 numbers. I can't even have 3. So I notice that this is 1 and 3. That I'm done factoring. Once I have 1 as one of the factors, I'm done factoring that specific number. But 9 can be 3 and 3. So what I notice here is I have 1, 2, 3 3s, and I needed 3 of the same number. So 3 here becomes my answer. But it's not 3 itself. Remember, my answer had to be negative. Okay, so that's what the core concept was saying. It was saying because n is odd and a is negative, my answer has to be negative. If n is odd but a is positive, then my answer is going to be positive, okay? Now, it's a little bit harder when n is even. When n is even, you're going to... The answers depend on what a is, honestly. So I need to remember I'm finding the 4th root of 16. Now notice how I wrote that and I said it. I said the 4th and I wrote the number 4. Then I said root, and I drew the radical sign, or we call that the root. Fourth root is how we would read these two together. Normally how I write them is just like that. I find it harder, and I did it earlier, but I do find it harder to actually write the radical sign than the root, okay? So I write them the other way. I write them the root and then the radical. Anyway, moving on. This is asking me to find 4 numbers that are the same that multiply up to 16. Well, I have 8 and 2. I also have 4 and 2. And then it goes on to, because 2 is a prime number, which means only 1 in itself multiply up to it. 4 and 4 are as integers. 4 and 4 is 2 and 2, and I count them 1, 2, 3, 4. And so I'm going to circle. Now, this whole circling deal that I'm doing will come in later to be more important than right now, but it's good to go ahead and see it and or do it. Now here I have 4, so I take all of those out, and that's my answer. Now, because 4 was even, technically these could be negatives, technically they could be positives, so we're going to assume that it's just the positives at this point. Well, no, we don't want to assume. I see what they're doing. Okay, I just looked at the notation in the book, and we're introducing, it looks like, or reminding some of you. I know in pre-algebra I introduced this. We're doing this. Instead of writing 2 and negative 2, this and is that symbol. The and is the same thing as that, so we don't have to write the other one. The negative that was right here is this, and the positive that's invisible right here is that one. So if we take this symbol and put it in front of a number, it means both positive and negative. Whatever that number is becomes our answer. So forgive me for not verifying that and getting that stuck in my brain to begin with, but this answer is saying both positive and negative 2. And thank goodness we don't have to write all of that. And even this gets shortened and means the same thing as plus minus 2.